So we don't have, the other one we had 3 sides, right? We have 2 sides of the big triangle and 2 sides of the little triangle, but we have to have another thing. If we only have 2 sides, what else do we have to have?
Angle.
An angle. Do we have an angle that's congruent?
No.
Do those 2 triangles, Desiree, were you going to say something? Do those 2 triangles share an angle?
Mm-hmm.
Q, correct? Isn't Q in both triangles?
Yeah.
Oh,
Yeah. So if Q's in both triangles, Q is obviously congruent to Q, yes? So since Q is congruent to Q, which one could I use?
Side, angle, side.
Okay, I could use side, angle, side. So we know we have a congruent angle. We need the other 2 sides to be proportional now, right? Correct? Okay, so what do you want to start with? Little or big?
Little.
Little. Okay, so 12 over 18 would be little, right?
Yeah.
Okay, so 12 over 18 would be little. And what would 12 correspond to? Now 12 is the shortest side.
To SP. Would it be SP?
Well, we don't have any information about SP.
What is it correspond to 15? Oh.
Okay, so 12 is the shortest side of PQR, correct? Okay, so what is the shortest side of PQS that I know? Well, SQ, what is SQ?
That's the whole thing. It would be SR.
Well, the whole triangle, what is this side?
The whole thing.
What is it? How much is that?
27.
It's 27. Because 15 plus 12 is 27. Correct? So we have 27 and 18. Which one is smaller?
18 over
18.
27.
So it's going to be 18 over 27. Remember, shortest goes with shortest, right? So 12 over 18, what does it reduce to?
4, 6. 2/3.
2/3. What goes in there 2/3 times? What number goes in there 2/3?
6.
6. So we divided this by 6. Okay? 18 over 27. Biggest thing that goes in 8. 9.
2 and 3.
So I get 2 and 3. So we know we have a congruent because angle Q is congruent to angle Q. Yes? And then we now know that I can't talk today. The sides are proportional. So it is a yes by what?
Starting with
By side, angle, side, and you have to put similarity. You can't just put side, angle, side. Because side, angle, side talks about congruent triangles. Okay, now we're going to use this picture for 2 things. So, is triangle ABE similar to ABD?
Well, they have an angle.
Okay, so we're looking at the 2 sides. We're looking at this angle, this triangle, and this triangle, right? Okay. Wait, no, we're not looking at that one. We're looking at this one and this one, right?
The first one we know.
So we have this one and this one. Okay. So, well, if I'm looking at those 2 triangles, I don't have angles, but I have all 3 sides, yes?
Yeah.
So they have to be proportional. So if it is, it's going to be side, 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 similarity, right? Okay, so 18 over what?
2.4.
2.4 is going to equal 1.8 over what?
2.4.
2.4 again, which is going to equal 2.4 over what? 3.2. Okay, since they all have one decimal place, I can multiply them all by 10, and that's 18 over 24, 18 over 24, and 24 over 32, correct? Since they all have one, do they all have one decimal place?
Yeah.
So can I move all of their decimals by multiplying by 10? Okay, so 18 and 24, biggest things that go into that.
6.
6,
3 and 4.
3/4. Well, obviously 18 and 24 is 3/4 again, right?
Yeah.
What about 24 and 32?
3 and 4.
8 goes in both, doesn't it?
Mm-hmm.
3 and 4. And the nice thing about it, guys, if you know what the proportion is, you need to look for something that's the same thing. So if it's not the same thing, then it's not similar, right? Okay, so is it similar?
Yes.
Yes? By what?
Side,
Side,
somewhere.
similarity. That's a lot. Side, similarity. Okay, so now we're going to be looking at 2 different triangles in the same picture because there's like 3 triangles in there, right? Okay, what are we going to be looking at now?
That's right.
A, B, E, so this one and this one. I was looking at this side first, wasn't I? Okay,
But I think.
we have an angle that's congruent, yes? Okay, so the only one with an angle
Side and
is side angle side or angle angle similarity, and we don't have 2 angles, do we? So it would have to be the sides that make those angles that would be similar, correct? Okay, so 1.4 would have to go with what? 1.8. And 2.4 would have to go with what? 2.4. Well, 2.4 over 2.4 is what?
1.
1 over 1. And I'm going to leave it 1 over 1 because we need to be a proportion, right? Or ratio. Is the other one going to be 1 over 1?
No.
No.
No, we already know it's going to be a no, but let's reduce it. Because I have 14 and 18, so what goes into 14 and 18?
2.
2,
2.
right? So I get 7 over 9.
9, yes.
Okay, so are they similar?
No.
Nope. And when somebody says why, did I just show why?
Yeah.
My math to figure it out also showed why it wasn't, didn't it? I think it's our last one. Oh, no, we got more. Ooh, look at all those. Okay. We're going to use the same picture though. Okay, what is MN? Well, first I have to know that it's similar, don't I?
It's similar.
It's similar. Okay, if they are similar, what's MN? Okay, so we have to have, what has to happen?
Well, LM is 1.
Well, this is 1 and this is 75, right?
Yeah.
So if it's similar, then this has to be proportional to 10, right?
Yes.
So how do I figure that out? That's what we did all last week, right? How do I figure this out? X over what? X over 10? Okay. Equals what?
75
75 over 1?
1.
1 over 75. Why does it have to be 1 over 75?
Smaller number on top.
We have to keep the smaller things on top. Now, could I have put X over 1 equals what? 10 over 75. Okay, could I put that also? Yeah? And if I would have done that, I would have been done with my work. Because X over 1 is just what? X. So I don't have to do anything, would I? I just have to reduce. But either way. So here I have to cross multiply, yes?
Yeah.
So I get 75 X equals 10 divided by 10, or 75. So X equals 2 and 115, right? 5 goes into both of those. So this is what we did last week, isn't it? Okay, so what happens, the next two are the what ifs. Just what ifs. happened, if I did it this way, I would also get what? 2 over 15. And I wouldn't have had to cross multiply, would I? Okay, so we're going to use this one as we go from here. Everyone good with that?
Yeah.
Okay, so what happens if JL were 150? So we'd have x over 1 equals, and where would the 150 go? At the bottom. So you 10 over 150. Well, 10 over 150 would just be what?
1 over 15.
1 over 15. Okay. Well, what happens if JK turns to 20? What part of my ratio would change?
The top number.
The numerator. So it'd be 20 over 75, right? Which reduced by 5 to 4/15? Yes?
Yeah.
Okay. So I want to look at all these. We started out with 2/15, yes? And then it went to 1/15. And then it went to 4/15. Well, what did I do to 75 to get to 150? 75 times what gives you 150? 2. So I made my denominator twice as big, yes?
Yeah.
But my answer is what of my original? Isn't it half?
Yeah.
2/15, 1/15 is half of 2/15, right? So I doubled my denominator and my actual answer went to half. Well, that's because I made my denominator, I'm dividing it by 2 more, aren't I? Okay, so over on the next one, I doubled my numerator, and what happened to my answer?
Double the
It doubled the answer, didn't it? So if I double my numerator, I'm going to double my answer. But if I double my denominator, I'm going to get what my answer? Half of it. Does that make sense?
Yeah.
Because the denominators you're dividing it by, right? So you're dividing it by 2 more. And the numerator I'm multiplying, so I'm multiplying by 2 more. So that's it. You have a worksheet today. Just let me stop this since we actually got